I think there's some good instructions here. Let's kind of walk through them a little bit. So we have two equations, two linear equations, and what we were doing the other day with substitution was we were looking to see if we could find the point algebraically where they cross, right, where they're true for both. And today is no different. We're just going to be working with slightly more difficult problems. So in this case, we've got x plus 3y equals 7 and 2x minus 4y equals negative 6. None of these four variables that were given in these two problems are solved. Hey, both of you guys, wake up. Staring into space or head down doesn't cut it when I'm instructing. So what we want to do is we want to pick one of these four variables to solve for. Now, I'm all for being a smart math student, right? So we want to pick the one that's easiest to get by itself. Any ideas which one of these guys is going to be easiest to solve for? Probably this one that doesn't have any coefficient to it. There's no variable, or there's no value other than 1 there. So that's why they've got this out over here. So what I want to do is I want to solve for x. So I'm going to subtract 3y to both sides. Hey Riley, that includes moving your hand with a pencil. Have you got a pencil? Okay. Write this down with me. Let me be clear. Either do this with me or go spend your time in the office. Are we clear? That's your choice, not mine. I'm giving you the choice. So I get x equals negative 3y plus 7. Okay, you're making the choice, bud. Now, once I've done that, now I can substitute this value in for x here, just like we did before. So what we did before is we were already given something that was solved for us, something that was easy. But now we have to make a quick change before we can do that. So then this is going to be 2 times this 2, negative 3y plus 7. So I'm replacing that x, minus 4y equals negative 6. So then what? I distribute, right? So this is going to be negative 6y plus 14, don't forget the 2 times the 7, minus 4y equals negative 6. And we combine like terms. Yes, Nathan.
Could you have divided by 2?
I could have. Yeah, I could have.
Would that give the y as a fraction?
No, because the 2 would have divided the 4 here, the negative 4, and the 6 evenly. I thought about showing it that way, but then I thought, no, I think most people tend to go for the distributing. But you're absolutely right. You could have divided by 2 there and made it a little easier, perhaps. At least slower numbers, you know. It'll work out the same either way. So if I subtract 14 from both sides here, then I get negative 10y equals negative 20. So what does y equal? 2, right? Yeah, divide by negative 10 and you get 2. Now here's the cool thing. Now that I've got that 2, I can plug it in to this, or this, or this. Where is it going to be easiest to plug into? I think that guy's going to do it. Since the x is already solved here, I'm going to take this 2 and I'm going to plug it back into that equation there. So x equals negative 3 times 2 plus 7. X equals negative 6 plus 7. X equals 1. So where the 2 cross is at 1, 2. So in these instructions it says substitute the y for either one of the 2 original equations. Well, most often it's going to make sense to plug it into the equation that you changed. That's going to be your easiest bet. So I don't necessarily agree with that statement. This is one of the 2 original equations. You just modified it to make it easier for that plug-in. Okay? So don't be afraid to use that guy. All right, so far so good. Let's look at a couple more. Most of these, to be perfectly honest, are still not on the difficult side of substituting. Generally, when it gets really difficult, we use a different method called elimination that we'll learn soon. But let's look at number 1 here. I can solve for this x, I can solve for that y, I can solve for this x, or I can solve for that y. You get to pick which one looks like the most friendly to solve for. Okay, you want to use this one, you're saying? But what am I solving for, the x or the y? The y, right. It has a negative, so we'll have to deal with that, but I think everything else is probably going to be easiest. So I'm going to solve for that guy right there. So there's not a lot of room. I'm going to rewrite this. So I'm going to subtract 3x to both sides. So I get minus y equals negative 3x plus 4. How can I make that y positive without going through a big division step? Yeah? Not distributing. That's a way. Change all the signs. If you want to change one sign in an equation, you just change all of them and you're good to go. So we can say y equals 3x. Almost put a negative there, didn't I? Minus 4. If I change all of the signs, that's the same as multiplying or dividing by a negative 1. Okay, nice little shortcut. So now I'm going to take this guy and I'm going to plug it in here for this y. So this is going to be 2x, let's see, minus 3 times, I'm kind of running out of space there. I'm going to erase a little bit of my line there. 3x minus 4 equals negative 9. They've tried to give us enough room here, but it's going to be a little tight. So I'm going to distribute the 3. Watch that negative there. That comes along with the distributing. So I get 2x. Negative 3 times 3x is going to be negative 9x. Negative 3 times negative 4 is plus 12 equals negative 9. Combine my like terms. And then we get, not add, I'm going to minus that 12. Subtract 12 from both sides. Negative 7x equals negative 21. What does x equal? Yeah, good. 3, right. 3. Divide by negative 7. So x equals 3. I'm running out of space. I plug the 3 back in here, because that's where it makes the most sense. 3 times 3 is 9, minus 4 is? 3 times 3 is 9, minus 4? 5. Good, thank you. So y equals 5. So my point, 3, 5. Feel free to do this work on another piece of paper. It does take a little bit of space. Let's see. How about number 3? Number 3 right below it here. I've got an x, I've got a y equals 16, and I've got a 2y equals negative 2x plus 2. I see a few different options here. Any thoughts? What do you guys think? Yeah, Nathan.
I think we should do the y because the y is positive. X is typically negative.
This y here? Is that?
The y in the x plus 16. We solve for it because the x is technically it's negative.
It's going to be negative if we move it to the other side, right?
Yeah.
Yeah, I see what you're saying. Yeah, okay, I'm good with that. Anybody else see a different step? We'll do it that way, Nathan. But here's the other thing. Here's the thing that I see. What if I divided everything by 2 here? Then I wouldn't have to move anything at all, right? Because then I'd have a y all by itself. So that would be the direction I would go. But I'm going to take your thought on that. So if I solve for x, I'm going to subtract x from both sides. I'm trying to sneak it in there. So I'm going to get y equals negative x plus 16. And then if I take that and I plug it in over here, oh, sorry, I didn't realize I was so far down on that. Now, Nathan saw something in a previous problem, though, where you asked if we could divide by 2 instead of distribute. Do you think we could do that here? Absolutely. I think we could. You could distribute. There's nothing wrong with that. But I'm gonna take you a different direction on this. Let's divide everything by 2. That gets rid of that 2 that's distributing. So I get negative x plus 16 equals negative x plus 1. I'm going to try to get my x's together next. Uh-oh, I got a problem. Or is it a problem? Equals 1. Yep, that's true. No, said nobody ever, right? Okay. No solution. That's right. It's a no solution problem. That means that these 2 lines are parallel. There's no solution. It's not that we've made a mistake. It's just that there's no solution. Let's see if there's any other something that we should look at here. Oh, I think we should do a couple word problems. Let's look at number 9. So story problems tend to be difficult, I think, for people. But if you work it out and think about it carefully, maybe it's not so bad. tickets to a concert cost $10 in advance and $15 at the door. So we're talking about tickets and how much they cost, right? So maybe I even make a note about that. If 120 tickets were sold for a total of $1,390, how many of the tickets were purchased in advance? Okay. So here's what I have. I've got money and I've got number of tickets. Do I know how many were sold in advance? No. Do I know how many were sold at the door? Are those different things? We do? Wait, yes? Oh, no, I don't think we do. Yeah. We don't know either one. Are they different? I mean, they still get you in, but yeah, they're different because one's $10 and one's $15, right? They're different tickets in terms of their cost and when they're sold. So if I said $10 for every advance ticket plus $15 for every ticket sold at the door, which is different than the X because it wasn't sold in under the same conditions. How much does that equal? That's the money one. $13.90. Good. Now, how many tickets did I sell in advance? Yeah, I don't know, X, right? And how many tickets did we sell at the door? Not X and X. Y, right? The at-the-door tickets were different. How are they different? They're more expensive and sold at a different time. Okay? Other than that, they're the same thing. Do we know how many tickets were sold? 120, right? Now, I have a system of equations. If I graph these two, somewhere they would cross. That's what we want to find out. Where would they cross? That'll tell us how many tickets at the door and how many in advance and how much for each in each instance. So I've got to solve probably one of these two guys. You want to solve for y? Let's solve for y. Oh, if we're solving for y, I guess I'm subtracting the x, huh? So I get y equals negative x plus 120. Yes?
Should we just divide 1390 by 120?
What's that going to tell you?
Do they show an average?
It will. It will show an average, but that won't tell you how much of each ticket. You're right about that. And we certainly could do that. If we wanted to know what the average price of the ticket was, then yeah, that would work. But it doesn't tell us how many of each, and that's really what we want to know in this case. So if I take this and I plug it then in up here, that's going to be 10x plus 15 times negative x plus 120 equals 1390. And we distribute. Let's see, 15 times negative x, negative 15x. I don't know if any of those are good. I'd trust that one. Probably need to sharpen it. 15 times 120. Let's see. 15 times 12, that's 180, so that's 1800. How did I do that in my head? I took 15 times 10 and said that's 150. And then 15 times 2 is 30. So I added 150 and 30 in my head. And then I added another 0 because we're multiplying by another factor of 10. So I got 180 plus another 0. Okay, so what do I get here? I get negative 5x. I can subtract the 1800. So negative 5x equals, let's see, I don't know, what is that? 410, negative 410. If I divide by negative 5. Is it possible to get a negative answer here? Yeah, you can't sell negative tickets. You could sell 0 tickets, but you can't sell negative. Let's see, 5 goes into 410. Let's see, I think that's 41 times. No, 82 times. Am I right? Let's check it. Yep. So we sold 82 tickets in advance. And that's all the question asks us to come up with. If we had solved and gotten y, then we would have had to sort of change it. How many were sold at the door then, if 82 are sold in advance? Yeah, 38. Good. Yeah, 120 minus 82. Good. So did you see how I set that up? How I realized in the context that I had two different ideas here, the number of tickets and the price? That's a good starting point when you're trying to set these kinds of things up. And the word problems can be frustrating. I know they can be. Once you've done about 4 million of them, then you start to feel like maybe you can get them every now and then, right? So you got to try them. You can't just go, oh, it's a word problem, I can't do that. You can. You just probably won't do it the first few times around, right? It's kind of like learning to do a backflip. Well, maybe that's a bad example. Front flip. Trying to learn to do a front flip on a trampoline or something like that. The first few times, you're probably not going to land on your feet, right? But if you do it enough, if you keep trying, eventually, you should be able to land it on your feet. On the back flip, you really don't want, you want to make sure you got it before you give it a go. Okay? All right, so let's get you going on the assignment itself. We do have a quiz today.